Hello world. Yes, ladies and gentlemen, today Tic Tac Toe, the classic app of all uh, beginners in coding. Before I show you the app, I want to share a story. I was talking to a friend who's also learning how to code about a Tic Tac Toe he made, and the following day I was learning about HashMaps, and then light bulb moment came and I thought, yeah, that's a perfect combination. I should make a tic-tac-toe game with hash maps. So what we'll need here is, of course, a hash map, then the field number, because the fields are numbered from 1 to 9, and every field has a state. The state can be empty, it can have a computer sign or our signs, which we can change here. For now we'll play with an X, and let's play, shall we? So there's no the game is played in the console. There's no interface. I think it's more about the thinking machine, the AI, if you will, for this app. It's not about fancy graphic interfaces. So let's run the app and let's start in the middle. We'll just play. As you can see, I put down numbers, which of course are represented here: 1, 2, 3, 4, 5, 6, 7, 8, 9. And then as always, it's going to be a draw. Let's see if we can let the computer win. Let's make some rookie mistakes and see if it can take advantage of it. So here, let's say the computer will go first. So the move computer method will be executed before ours, and then there's check for win method after every move. I'll show you the method later. Of course, first let's see how the AI works and if it can take advantage of our mistakes. So surely if we place our X in the corner, it can guarantee itself a win. Or is it another way? It will be. It's another way. You should put it in the corner, not on the side. But anyway, let's make a mistake and see if the computer can take advantage of it. Sure enough, it can. So it seems our AI works. So let's go through the code and see why and how it works. First, we have the game setup, and we have fields numbered from 1 to 9, and they all start with a dash, which means that they are empty. And then we have our hash map, where we put the field number and the state of the field. The order doesn't really matter because all of them will have dash at the beginning. That's why we can use a hash map here. So we have move player method, which of course self-explanatory is our move. We need a scanner for it, so our input is taken here, and then the computer, the game needs to check if it's indeed a number from 1 to 9. This is how we achieve it. And if indeed it is, the player can make a move. So there are two cases in which the player cannot make a move. First, if the player gives wrong number, or actually if it gives something that is not a number, then it just closes the app, because come on, how you know what I mean. But if the number is bigger than 9 or lower than 1, then we just advise to give the correct number. Another way where the player cannot make a move is when the field is already taken. So if the field state is not dash, means the field is not empty, and therefore you cannot make this move, but you of course have a chance to move again. And then after the move, it has to update the matrix, so all the field states are taken here. And if so this is how we achieve the matrix. Every three fields it has to go down for it to make a graphic sense. And then we have a method move computer at random, which is let's call it a stupid version, yeah, of the AI here. It just chooses a random number. Of course, you can play with it. I mean, the other method is a method where the computer is the smartest it can get in Tic Tac Toe. But the way you can play with it is you can delete some lines from the smart computer here. So, for instance, it can realize where it has a winning opportunity with horizontal or vertical setting, but cannot realize the diagonal opportunity for a win. You can just play with it, but I didn't make any intermediate setting or anything like this. You're either playing the stupid computer or the smart computer. So first thing it does is checks for wins, for which we have the two signs it needs to check, and the two signs method is here. It's actually not a method, it's a boolean, sorry. So if there are two signs, two fields, for instance 1, 2, 3, and the computer sign is the one we're checking, we're just comparing the two signs. If two of them are the same and one of them is a dash, then the computer can see it's a good opportunity to win, it's a sure opportunity to win, and it places its sign where the dash is. Otherwise the boolean is false, so the game continues. So there's a lot of code here, because obviously you need to I needed to compare every possibility. But after it goes for a win, if there's no opportunity for a win, the computer checks if we have an opportunity to win in the next move, so it blocks us. It achieves the same way with two sign boolean. And then first the computer checks if the 5 is free, because if the middle field is the one crucial to win. And then it makes sure that it doesn't use the fields on the sides, but rather for the corners. So it's pretty much achieved the same way. You put the hash map, you check the hash map. If the field in 5 is empty, you put the computer puts its sign there, and so on and so forth. It just checks the fields I mentioned here to make sure that it attacks and defends itself, just in case something goes wrong. There's an error the computer receives, but it never happens. And then after the computer move, we also need to print the matrix. It's achieved exactly the same way. Then, as you saw before, after each move we have check for win method, and this is how we check for win. Of course, we need to check if there's a line, or where if there's a line, straight or diagonal, that has 3 equal signs. So that's how it's checked. Simple if statement. And then if there is indeed such occurrence, then the sign wins and the game is closed. However, if none of these conditions is met, we need to check if the game can continue, or if it's a draw. When does the computer know it's a draw? Where in this simple application it knows when there's no moves left, what means no empty fields, which in turn means there are no fields with a state of a dash. And for that we need to check every value of our hash map. To remind you, hash maps have keys and values, so we need to stream the values, so go through them, in other words. And if none matches the given string, which we pass as parameter, the string is dash. If there's no dash, and we checked earlier there's no win for either side, then the game announces a draw and closes itself. So that's it. I hope you liked my HashMap Tic Tac Toe game. As always, the code is available on GitHub. You can I encourage you to watch my other YouTube videos, and I'll see you very soon. Bye.